Lesson 10.4, I really want you for this lesson, when I say pause the video, to pause the video and try to work out the couple of few problems that I have suggested you try. It's not something that I've ever done before in videos, certainly not all that much, but I definitely want you to try that today. I want you to have a clean printed copy of the notes. I'm sure many of you don't bother doing that. You just watch the videos and then just print my copy of the notes. Maybe you've done that already. If you have, set those aside and print out a clean copy of the notes. I really would like you to try the problems as we go. All right. And then this video is probably going to be a little bit shorter because of that, the actual video. But that'll be made up for by the time you put into trying the problems. Okay, so pause it right now and go print a copy if you can. All right, so today's lesson is about the Pythagorean theorem, which I'm sure you are all familiar with. Pythagorean theorem. Okay, oftentimes put as a squared plus b squared equals c squared. What do the A and the B and the C stand for? The A and the B stand for what we call legs of a right triangle. The C stands for the hypotenuse of the right triangle. The hypotenuse of a right triangle is, by definition, always the side across from the right angle. And as it happens, it's also the largest of the three sides of a right triangle, always. Okay? But for sure, the way to identify it is by seeing the side across from the right angle. The A and the B and the C are just random letters that somebody chose way back in history. They don't have to be A, B, and C. They can be X, Y, and Z. X squared plus Y squared is equal to Z squared. You can use absolutely any letters at all, but the one letter that's by itself on one side of the equation must always stand for the hypotenuse of the right triangle. So here's the first time I'm going to ask you to pause this video. I want you to try to work through these three problems here in this row and come up with the exact values of X in all three cases. Okay, so pause the video and go. All right, so here's my work for these three problems. Probably most, if not all of you, got the first one correct. X is equal to 17. My guess is that some number of you got incorrect answers for the second two problems for this particular reason. My guess is some of you did this sort of thing for number two. You added 12 squared and 13 squared. Maybe you didn't even write down an equation. Maybe you didn't even bother writing down equals x squared. 313 equals x squared, and then taking the square root of both sides, square root of 313 equals x, at which point you may have thought to yourself, I have no idea if that can be reduced or not. Maybe some of you have already forgotten that converting the square root of 313 to a decimal and throwing away decimal places is not considered simplifying the number, but rather approximating the number. The exact answer to this question in its most simplified form would be square root of 313, but look at what writing this as a decimal does for us. It allows us to look back at the picture and decide whether or not that answer seems reasonable. I mean, look at the diagram. Does that segment that I highlighted in red appear to be longer than the 13 and the 12 segments? I mean, if this answer is correct, then that segment is longer than either one of those. Well, it can't be long. It can't. It's not even just that, but because Mr. Nortillo promised good pictures. This is the hypotenuse. No leg, no other side of this triangle can be as long as the hypotenuse. This can't possibly be correct, right? So what went wrong here? What went wrong is we put the x, the variable, in the position of the equation that is reserved for the hypotenuse. This is the correct way to begin solving this problem. The x does not go on the lone side of the equation, where it's by itself, it goes on the side of the equation where it is being added to the square of one of the other, or the other leg in the triangle. And the 13 here goes in the position reserved for the hypotenuse. So then after you square everything, you got to subtract 144 from both sides, and then take the square root of both sides. Okay? And if you made that mistake on the second problem, you almost certainly made the same mistake on the third problem. Okay? The additional catch to the third problem is that the square root of 44, which is what the exact answer turns out to be, can be simplified as a radical as follows, and you get 2 radical 11. Okay? So this is a common mistake. Even after I teach this lesson and people do the homework and we get to the quiz and we get to the test, still, after all that practice, some people make that very common mistake of putting the variable in the incorrect position in the equation. So please be careful about that. Right? Here are 3 more problems that I'd like you to do. And there's lots of radical expressions in these. But now that you've learned about the very real possibility of making the mistake of not putting the variable in the right position, hopefully you don't make that mistake at all on these 3 problems. But really more the challenge of these 3 problems is dealing with all those root expressions properly. You're going to have to square all of these expressions with roots in them. Let me just give you a quick example here. Remind you, the square root of 83 times the square root of 83 is, anybody? 83. You don't need a calculator for that, right? You don't need to reach for your calculator and do square root of 83 times square root of 83, or do 83 times 83, get some huge number, and then take the square root of that. You don't have to do that. We know it's going to come out to be 83, right? And so likewise, the square root of, let's choose a just slightly different number this time, 89 squared is, anybody? 89, okay? So when you're squaring all of these square root expressions, you should be able to get results without resorting to a calculator. Now, in the very first problem, the 3 radical 2, 3 radical 2, when you square it, isn't, well, that's a little bit more complicated, a little bit more work. You got to multiply 3 radical 2 times 3 radical 2. Anyway, get going. I'm going to pause the video, write out my work. You pause the video right now, and you do your work ahead of me. All right, so here's my work for these 3 problems here. The first one comes out to be 3 times the square root of 6. The second one comes out to be x equals exactly 1. And the last one, x equals the square root of 6. Okay. I'm not going to add any more comment to those, but if you've made a mistake, all my work is there very clearly. You should be able to figure out what you did wrong. I will say this, for a problem like this one here, when it comes to the quiz, I am going to want to see you show your work to solve the problem for sure. I'm not going to need to see this much work, okay? I would be totally fine. First of all, I want to see this equation. If you got immediately down to this line in your very next line of work, you showed me this equation and then you showed me this, I don't need to see the 3 steps in between, okay? And then it would be good to show this and then this and then, I don't know, this and this. But I mean, these 3 steps here, really not necessary to show me those. But I want to see the original equation with things all plugged into the proper places, and then some work for sure following from that to the solution. Okay. Next 2 questions. Which of these sets of lengths make a right triangles? That's wrong. Make right triangles. Okay. Let me clarify the question. Suppose you had sticks, sort of like my pen here, and one stick was 3 centimeters, the other was 4 centimeters, the other was 5 centimeters, and you put them together end to end. 3, 4, and 5. No overlapping, no crossing over, but just end to end to end. The question is, would they make a right triangle or would they not? Same with the 13 and the 14 and the 15. Any ideas out there about how you would go about answering that question? It's a yes or no question. So, I mean, if you're guessing, you got a 50-50 shot at it, I guess, but you don't want to have to guess. How would you answer that question? Sticks with 3, 4, and 5 centimeters, you put them end to end to end. How would you decide if they would necessarily form a right triangle or not? Well, we're in a lesson on the Pythagorean theorem here, right? If sticks of lengths 3, 4, and 5 are going to make a right triangle, then those three numbers are going to have to fit the Pythagorean theorem. Okay? So let's find out if they do fit the Pythagorean theorem. Now, the one issue here is that I just sort of drew this triangle randomly. I don't really know where the right angle is, so I don't really know which of these three sides has to be the hypotenuse. So I don't know which number to plug in for C. Or do I? I mean, think about it. If this is a right triangle, one of these three numbers has to be the hypotenuse and the other two can't be, right? Which one would have to be the hypotenuse? The 5, because it's the longest of the three sides. So I know I've got to plug the 5 in for the C. And then let's check this to see if this is really a true equation. 3 squared is 9, 4 squared is 16, 5 squared is 25. Is 9 plus 16 equal to 25? Yes, it is. So those three lengths would form a right triangle. And with the 13, 14, and 15, do the same thing. The 15 would have to be the hypotenuse because it's the longest. This is 169, this is 196. 15 squared is 225. 269 plus 196, add up to 225. No, false. That's all there is to it, okay? Let's go down to the next page here. I want you to find the exact value of B. There are lots of unknown segment lengths in this diagram. There's an A, a B, a C, a D, and an E. Ultimately, I want you to find B. I don't know if you're going to have to find all of those other variables on your way to finding B, but I will tell you this, you can't find B immediately until you find at least one or more of the other variables. Okay, so pause the video now and get to work on this one. I've suddenly lost the tool that pauses my recording. This is the first time I'm doing with this. No, don't do that. Oh, son of a gun. All right, well, I'm going to finish this video the way I ordinarily would. But hopefully you've paused it to do your work and now you're watching me fumbling. All right, so we can't find the B because we don't know the A and we don't know the C. We could find the A, right? A, oh, son of a gun. Know what I noticed here? I forgot to put all the right angles in this picture. Doggone. Well, here. If you resumed this video because you thought to yourself, rightly so, hey, we can't find any of these segment lengths because there's no right angles in this picture. Pause this video one more time now that you know there are supposed to be right angles in this picture and try to solve for B, okay? Okay, if you're back once again, having tried with all the right angles, we can find the A because A belongs to a right triangle that has two sides known. Anytime you know 2 out of the 3 sides of a triangle, of a right triangle, you can find the third. Okay, so let's move myself out of the way here so we can do some of the work. We can find A, right? 5 squared plus a squared is equal to 10 squared. The a doesn't go on the right side of this equation. It's not the hypotenuse, right? So 25 plus a squared is equal to 100. Subtract 25 from both sides. You get a squared is equal to 75. And so a is equal to the square root of 75. Now, if you made the effort to simplify the square root of 75, okay, good for you. But here's the thing. We're not done with the problem. We haven't found the value of b yet. That's the only answer that I want. When you get the value of b, I will want it simplified. But at this point, there's no need to simplify a. It would turn out to be 5 radical 3, so congratulations if you got that right. But look, I'm probably going to have to square the a value on my way to finding the b value. Okay? So if you're thinking ahead, it might occur to you, what is the point of simplifying the square root of 75 when, as I continue through the problem, I'm just going to have to square that answer, which is going to get me back to 75 without a square root symbol in it. So I'm not going to simplify the square root of 75 right now, okay? So now you're looking at the problem and you're thinking, well, I got A, but I still don't know how to get B or C or D or E. Oh, wait a minute, it looks like we could get E. So you set this up and you write 3 squared plus 4 squared is equal to E squared. E is the hypotenuse, so E goes by itself. 3 squared plus 4 squared is 25. When you add that all up, take the square root of both sides, and E is equal to 5. Okay, so I've got E is equal to 5 and A is equal to root 75. Now, at this point, you might have been feeling pretty good about yourself if you got this far, and then you might have gotten stuck and thought to yourself, what do I do now? I don't have enough information to go anywhere else. And if you got stuck at this point, if you got this far and you got stuck at this point, okay, here's what you failed to do. You failed to write these answers in the diagram. Okay. And I don't know that I said this a whole lot last semester, but I may be saying this a lot this semester. Anytime you're working on a problem and you get sort of an intermediate answer, like you get some sort of result, but it's not the final answer, okay, if you can add that intermediate result into the diagram, you should, because it then may open your eyes to what you need to do next to solve the problem. Right? So if we put that square root of 75 right here, and if we put that 5 right here, then you may realize that there is another variable that we can now find. Right? We found the A, we found the E, there's a B and a C and a D still in the diagram. Do any one of those 3 variables, the B, the C, or the D, belong to a right triangle where we know the other 2 sides? Well, not the B. The B only belongs to one triangle, and we only know one of the 3 sides. And not the C. The C belongs to 2 triangles, but in neither one of those triangles do we know 2 out of the 3 sides. But the D does belong to a triangle where we know 2 out of the 3 sides. We just put this 5 here in the picture, and look at this triangle here. Now we know 2 out of the 3 sides of that triangle. So we can find D now by writing 4 squared plus 5 squared is equal to D squared. This all adds up to 41 is equal to D squared, so D is equal to the square root of 41. And that doesn't simplify at all. You can't simplify the square root of 41. Do not turn it into a decimal value. For goodness sakes, don't turn any of these numbers into decimal values. I want the exact value of B. If you turn any of these into decimals and work with those decimal numbers in future calculations, you're probably going to throw away decimal places, you're going to be rounding numbers, and immediately you are on your way to an inexact answer. Okay, so don't do that. Right? And now that I've got the square root of 41 in let's get a different color here in the picture. Now I got this triangle here where I've got 2 out of the 3 sides. So I can find the C. So now watch, here's where not simplifying or turning this into a decimal pays off. Because now I'm going to write C squared plus square root of 41 squared is equal to 9 squared. And some of you might be thinking, whoa, Mr. Nortillo, wait a minute. The C doesn't go there. C is always the hypotenuse. And I remind you that no, C doesn't have to be the hypotenuse. The letters can be anything you want. This C is a leg in this right triangle. It's a leg. It's not the hypotenuse. And that's allowed. You can use C for a leg. You don't have to use it for the hypotenuse. The hypotenuse is the 9. The 9 is what goes by itself in this equation. Okay, so please don't get confused about that. Now let's solve this equation. C squared plus, what is the square root of 41 squared? It's 41, right? And then 9 squared is 81. Subtracting 41 from both sides, you get C squared is equal to 40. And so C is equal to the square root of 40. I'm not going to simplify that square root of 40, although you could. It would end up being 2 radical 10. And now, finally, I have 2 out of the 3 sides of the triangle that B belongs to. All right? I've got the square root of 40, and I've got the square root of 75. The square root of 75 is the hypotenuse. So here goes the last equation. B squared plus square root of 40 squared equals square root of 75 squared. This is easy to do without a calculator. We know that square root of 40 squared is 40. The square root of 75 squared is 75. You see, if I had turned this right up here into a 5 radical 3, then I would have had to square a 5 radical 3 down here instead of a square root of 75. That would have been more work. It all would have been a waste of time, right? So subtracting 40 from both sides, I get B squared is equal to 35. And so B is equal to exactly the square root of 35, which does not reduce. Now, if this final answer, the value of B, could be simplified as a radical expression, then you should. None of the others were worth simplifying because we weren't done with the problem. And simplifying them would have just created more work than we needed to do. Okay? So, big lesson of a problem like this. 2 big lessons. Number 1, anytime you have a right triangle with 2 out of the 3 sides known, you can find the third. The other big lesson is anytime you've got a problem where you need to do some calculating and get some results that are not the final answer results, add that result to the diagram, and you may be able to see more clearly the next step that you have to take. All right. The homework is 4 pages of problems. It's a lot of problems. It may look like a lot at first glance, but the vast majority of them should go very quickly. All right. Make sure you have enough time to do it. A couple of problems towards the end are going to be a little bit longer, more involved, and may give you some pause where you have to think a little bit and make some decisions. Make sure you have enough time. All right. Take care. See you.